What if 3I Atlas isn't just a comet? Using principles from Dr. Michio Kaku's theoretical physics, we explore the von Neumann probe hypothesis, self-replicating alien spacecraft that could explore the galaxy autonomously. Harvard scientists suggest 3I Atlas might be exactly this kind of technology. In this video, we dive deep into how advanced Type 2 civilizations could send autonomous probes across interstellar space, why 3I Atlas matches the profile, and what the physics of self-replication tells us about exploring the cosmos. This is part 2 of our 3I Atlas series, examining this mysterious interstellar visitor through Michio Kaku's lens of theoretical physics. In my last video, we explored what 3I Atlas is and why it's causing such intense debate in the scientific community. Today, I want to take you deeper into one of the most fascinating theories about this interstellar visitor. A theory that, if true, would fundamentally change our understanding of intelligence in the universe. I'm talking about the von Neumann probe hypothesis. And by the end of this video, you'll understand why some of the world's leading physicists think 3I Atlas could be exactly this kind of technology. Dr. Michio Kaku has spent decades explaining how advanced civilizations would explore the galaxy. He's outlined the technological progression from Type 1 to Type 3 civilizations on the Kardashev scale. And one of the most elegant solutions to galactic exploration that physics predicts is something called a von Neumann probe. Named after mathematician John von Neumann, these are self-replicating machines that could theoretically explore every star system in the galaxy without requiring faster-than-light travel. Let me explain how this works and why 3I Atlas fits the profile almost perfectly. The concept is brilliantly simple. An advanced civilization builds a probe, a sophisticated spacecraft loaded with artificial intelligence, mining equipment, and manufacturing capabilities. They launch it toward a nearby star system. The journey might take thousands of years, but that doesn't matter, because the probe is autonomous. When it arrives at the target star system, here's where it gets interesting. The probe doesn't just gather data and move on. It uses resources from asteroids or moons in that system to build copies of itself. Maybe it creates 2 copies, maybe 10, maybe 100. Each copy then launches toward different star systems, and the process repeats. Do the math on this. If each probe creates just 2 copies, and each generation takes 1,000 years to reach a new system and replicate, within a few million years, you could have probes visiting every star system in the galaxy. A few million years sounds like a long time, but the galaxy is over 13 billion years old. If any civilization anywhere in the Milky Way developed this technology even 1 billion years ago, their probes could be everywhere by now. That's the profound implication Dr. Kaku emphasizes. You don't need warp drives or wormholes to explore the galaxy. You just need patience, automation, and the physics of exponential growth. Now let's talk about 3I Atlas specifically. Professor Avi Loeb from Harvard, along with several colleagues, published analysis suggesting we should seriously consider the possibility that some interstellar objects could be artificial. Not little green men and flying saucers, but automated probes from ancient civilizations. Why would they think 3I Atlas might be one? Let me walk you through the evidence that makes physicists pause. First, the trajectory. 3I Atlas is on a hyperbolic orbit, meaning it came from outside our solar system and will leave again. That's expected for an interstellar object. But here's what's interesting. Its path brings it remarkably close to the inner solar system, past Earth and Mars, directly toward the Sun. If you were designing a probe to explore our solar system, you'd want it to pass through the habitable zone where liquid water can exist. You'd want it to get close enough to detect planets with atmospheres, to analyze chemical signatures, to search for signs of life or civilization. 3. iAtlas's trajectory does exactly that. Second, the timing of its activity. Natural comets typically become active when solar radiation heats their surface enough to sublimate ice into gas. This usually happens around Mars' orbit or closer. 3I Atlas became active much farther out, beyond Jupiter, where solar radiation is weak. What energy source could drive such early outgassing? For a natural comet, this is puzzling. For an artificial probe, it could be a controlled release of material, perhaps part of a deceleration system or a way to adjust trajectory. Third, the chemical composition. James Webb Space Telescope analysis shows 3I Atlas is unusually rich in carbon dioxide compared to solar system comets. It also contains organic molecules, water ice, carbon monoxide, and other compounds. Now here's the intriguing part. If you were building a self-replicating probe, you'd need raw materials: carbon, hydrogen, oxygen, nitrogen, the building blocks of organic chemistry, and also the building blocks of life. A von Neumann probe designed to replicate using resources from comets and asteroids would naturally accumulate a coating of these materials over billions of years of travel through interstellar space. It might look chemically identical to a comet, even if there's something artificial underneath. Fourth, structural integrity. Dr. Loeb points out that 3I Atlas will reach perihelion, its closest approach to the Sun, on October 29th. Natural comets often fragment at perihelion due to thermal stress and tidal forces. If 3I Atlas survives intact without breaking apart, that tells us something about its internal structure. It suggests the object might be more robust than ice and rock held together by gravity. Of course, some natural comets do survive perihelion intact, so this alone isn't conclusive. But it's a data point worth noting. Now, let's think about this from Michio Kaku's perspective of theoretical physics. What would a von Neumann probe actually be made of? How would it work? The physics is surprisingly feasible. You'd need advanced, but not impossible technology. Artificial intelligence capable of autonomous decision-making over thousands of years. We're already developing AI that can learn and adapt. Mining and manufacturing equipment that can process raw materials in zero gravity. We're beginning to test these capabilities with asteroid mining concepts, a power source that lasts millennia. Nuclear reactors or perhaps fusion technology could provide this. And critically, the ability to survive the harsh environment of interstellar space for millions of years. That last point is crucial. Interstellar space is brutal. Cosmic radiation, micrometeorite impacts, extreme cold, the vacuum of space. Any probe traveling for millions of years would accumulate damage. How would it survive? One solution physics suggests is a protective coating. Imagine the probe deliberately gathering ice and dust as it travels, building up a shell of material that acts as radiation shielding. From the outside, it would look exactly like a comet. The icy exterior protects the machinery inside, while also providing raw materials for potential replication. This isn't science fiction. This is practical engineering informed by physics. Dr. Kaku often discusses how we would detect advanced technology. He emphasizes looking for things that appear natural, but behave in ways that betray artificiality. Small deviations from expected behavior, non-gravitational acceleration, unexpected changes in brightness or rotation, radio emissions, heat signatures inconsistent with a natural object. So far, 3I Atlas hasn't exhibited any of these obvious signatures. No radio signals detected, no clear course corrections. It appears to follow a purely ballistic trajectory, determined by gravity and its initial velocity. But here's where the physics gets subtle. A truly advanced probe designed by a Type II civilization wouldn't necessarily broadcast its presence. Think about it from their perspective. If you're a civilization sending billions of probes throughout the galaxy, you'd want them to be stealthy. You don't know what other civilizations might be out there, whether they're friendly or hostile. The safest strategy is to observe without being observed. A probe that looks and behaves exactly like a natural comet would be the ultimate camouflage. It could gather data about our solar system, about Earth, about whether we're developing technology, and transmit that information back toward its origin, using tight beam communications that we couldn't easily detect. This leads to a fascinating question that Dr. Kaku explores in his work. If von Neumann probes exist and have been exploring the galaxy for millions or billions of years, how many could be in our solar system right now? Think about this. We've cataloged millions of asteroids and comets. We're constantly discovering new ones. What if 1% of them, or even 1/10 of 1%, are actually ancient probes? We wouldn't necessarily know. They'd look like rocks and ice. They'd orbit according to the laws of gravity. Only detailed analysis of their internal structure or unexpected behavior would reveal their true nature. This brings us to the Fermi paradox, which Kaku discusses extensively. If the universe is teeming with civilizations, where is everybody? Why haven't we detected obvious signs of alien intelligence? The von Neumann probe hypothesis provides one possible answer. Maybe we have detected them. Maybe they're all around us, disguised as natural objects. Maybe 3I Atlas is one. Maybe dozens of the asteroids in our solar system are. They're just being so subtle, so patient, so well camouflaged that we haven't recognized them yet. Now, I need to be absolutely clear about something. The scientific consensus is that 3I Atlas is almost certainly a natural comet. The vast majority of astronomers and physicists who've studied the data believe it's a piece of another planetary system, a chunk of ice and rock ejected into interstellar space billions of years ago, now passing through our cosmic neighborhood. Every measurement, every observation, every piece of spectroscopic data is consistent with this explanation. There's no smoking gun that demands an artificial hypothesis. But, and this is important, the absence of evidence is not evidence of absence. Dr. Kaku and Professor Loeb argue that we should at least consider the possibility and look for ways to test it. That's how science works. You don't dismiss ideas just because they sound extraordinary. You examine them, you propose tests, you gather data. That's exactly what's happening with 3I Atlas. Telescopes around the world are monitoring it. Spacecraft are observing it. Scientists are analyzing every piece of information. So what would conclusively prove 3I Atlas is artificial. A few things. If it changes trajectory in a way that can't be explained by gravity or outgassing, that would indicate propulsion. If it emits radio signals or other electromagnetic radiation that doesn't match thermal emissions from a heated comet, that would indicate technology. If its internal structure, somehow observed through radar or other means, shows geometric patterns or materials inconsistent with natural formation, that would indicate design. If it breaks apart and the fragments show any kind of manufactured components, that would be definitive. None of these things have been observed. But here's the critical point. October 29th is the moment of truth. When 3I/ATLAS reaches perihelion, it will be under maximum stress. If it's going to break apart, that's when it would happen. If it's going to exhibit unexpected behavior, that's when we'd most likely see it. Scientists are prepared with multiple observation campaigns. Hubble, Webb, ground telescopes, even spacecraft near Mars, all pointed at this one interstellar visitor. Whatever we learn will either confirm it's natural or raise new questions. Let's think about what happens if it is a von Neumann probe. What would that mean for humanity? Dr. Kaku explores this in his discussions of First Contact. If 3I Atlas is artificial, it's been observing us. It knows we're here. It's probably been gathering data about Earth, our atmosphere, our civilization, our technology for months now. That information, transmitted across interstellar space at light speed, would take years or decades or centuries to reach whatever civilization built it, depending on their distance. Would they respond? Would they send more probes? Would they eventually send a crewed mission? Kaku points out that any civilization capable of building von Neumann probes is, by definition, far more advanced than we are. They've mastered self-replicating nanotechnology, artificial intelligence, interstellar navigation. All technologies we're just beginning to develop. The question becomes, what are their intentions? Are they simply exploring and cataloging, like cosmic scientists? Or do they have other purposes? Physics can't answer that question. We can calculate trajectories, analyze chemical compositions, model thermal dynamics. But motivation, intention, purpose, those are beyond the reach of equations. That's why the discovery of even one confirmed artificial object would be the most profound moment in human history. It would prove we're not alone. It would demonstrate that intelligence arises elsewhere in the universe. It would show that civilizations can survive long enough to develop incredible technology. And it would raise the question, what should we do next? Here's something Dr. Kaku emphasizes. If von Neumann probes are real and common, then the galaxy is probably filled with them. Every star system could have dozens or hundreds quietly observing, gathering information, occasionally replicating, and moving on. The universe would be far more populated than it appears. We'd be living in a galaxy where intelligence is ancient and widespread, but subtle and patient. That's a very different universe than the empty void we often imagine. For now, 3I/ATLAS remains a mystery. A fascinating, provocative, scientifically valuable mystery. Natural comet or ancient probe, it's teaching us about the cosmos. It's pushing the boundaries of our technology as we strain to observe and analyze it. It's forcing us to think about the possibilities physics predicts for advanced civilizations. And it's reminding us that the universe is full of surprises, that every interstellar visitor carries information about worlds we'll never visit, about history spanning billions of years, about the fundamental question of whether we're alone. In just a few days, on October 29th, we'll get crucial new data. Telescopes are ready. Scientists are prepared. Whatever happens at perihelion will either put the artificial hypothesis to rest or raise fascinating new questions. Either way, we learn something valuable. Either way, we take another step toward understanding our place in the cosmos. So what do you think? Is 3I Atlas a natural comet from another star system? Or could it be a von Neumann probe, an ancient explorer sent by a civilization millions or billions of years ago? Could both explanations be possible, with the truth somewhere in between? Share your thoughts in the comments. I read every single one, and I love seeing how you apply physics and logic to these questions. Make sure you're subscribed, because my next video will cover the October 29th perihelion observations. We'll analyze the data together, look at what scientists discovered, and discuss what it means for the von Neumann probe hypothesis. This is real-time science happening before our eyes, and I want you to be part of it. The universe is speaking to us through visitors, like 3I Atlas. Let's listen carefully to what it's saying. Thanks for watching.